My name is Magnus Ullman. You recognize me, but not all of you might know that what I do normally and what we don't do normally is not boat shows, but ergonomics, protecting the guys that are going on the boats. And I got a little creative after dinner last night, so I added some slides. So I'm gonna do 55 slides in 15 minutes. So we'll see how it goes, but I'll be quick. So let's talk cockpits. This is just an example of how we work, how many features and gadgets you can analyze and get into a simple thing, which is basically a box with a windscreen. Let's start with where to put the console, all right? There's been some discussion. I think the general consensus about who wants to go up front is that the passengers, the boarding team, they want the drivers up front, and the drivers want the other guys up front. Everyone knows this intuitively, it's worse up front, so how much worse is it? Forward, center, and aft console, of course, this is a discussion, depends on configuration, on task, what you're gonna do with the boat, but there are figures. This study is interesting because it is a big selection of boats over a long time. They measure midships, in the bow, and on the stern. 33 to 80 foot boats, so fairly big boats, but also fairly high speed, so it is relevant data. What you get on this graph is that the impact in the bow is more than twice the impact you get in the center of gravity, the longitudinal center of gravity. The impact in the stern is 24% less than you get midships. Those are the figures. Just good to know. So what you already know, here are the figures over a big selection of boats. Then that might, of course, vary, but it's up to you where to put the console, but there are pros and cons with everything, of course. So let's talk about posture. Let's talk about how we can make this. You don't have to be a doctor to see that this is not great. He's not going to be as good doing what he does standing like this as standing like this. So we want to bring this guy back here. We want to bring this guy his instruments. This is very important. This is his job. A lot of you guys drive boats. Some of you don't drive boats. But those of you who do deserve to have at least as good working environment as those of us who run desks. How do we get from here to here? I mean, this is not made up. These are actual boats. This is actual, all of these pre-pictures are actual designs. Depending on how late in the process we get involved, you can't always fix everything, but you can always improve. And going from here to here does not cost a lot of money, but it's going to make this guy's job a lot easier. How do we do this? So I'm just going to walk you through the steps that we take and what we ensure in each step. A lot of the boat builders here, I would say most of them, they know this. They got the hang of it. The cockpits now are so much better than they were 10 years ago. Still, there can always be improvements. So here is a normal sit-down cockpit. You put the guy in the cockpit. You make sure that he fits. The first thing you look at is sight lines. We don't look at instruments yet. We make sure that especially the driver, but of course everyone on board, has a good vision of where they're going and as much as they can see. Not just over the console, you need to see over the bow. You need to consider the approach of the boat, the angle. You need to consider if you have a sunroof. One example, not very long ago, we had a boat with a big top, looking very menacing. But it turned out as soon as they turned a little bit, they could only look 2 degrees into the turn, which is a quite dangerous thing. You don't realize that until you actually mock it up and see that it's great for the sun, but you need to be able to look up into the turn as the boat is leaning in. So sight lines looking out, that is priority 1. Priority 2, sight lines for crucial instruments. So the area you have in the next, the second viewing field, that's what you can observe at speed. This is as much as you can absorb and process when you're going fast. Don't overcrowd this surface. Put the critical instruments there for each role. Don't put everything there just because you have the space, because too many belts, too many dials, bells and whistles are just going to be confusing. So keep the critical area critical and put everything else that you don't need to observe somewhere else. Identify extra surfaces you have. So this might not be a great place for display, but it is a big surface that's not in the way, it's not interfering. You can put things there. And don't forget to add, glove compartment or small things where, because the guys they have their water bottle, they have their gloves, they might have a headset to put somewhere. I mean, add those little things if you have the space for it. You have the surface behind the wheel. You can't put any visual instruments there because you're obstructed by your arms, but you can put tactile, you can put buttons where you can feel where they are. You can put, of course, the key. You can put things that might stick out, but that you don't need to look at. Consider reflections. Consider reflections from the screen. A closed boat is much more forgiving because you don't get that much glare and reflections, but in an open boat it's very important that you get the reflections down into your body instead of reflecting the sky. Now, everything up till now is just view, sight lines, placement. Now we can look at reach. Make sure that this guy does not have to reach to grab the wheel. Bring it back. Of course, that happens during my presentation, but I guess it's better than someone else's. And it's back. Okay. Yeah, so bring the instruments back, make sure there's room for the feet. Add longitudinal adjustment if you need it. This type of cockpit might need it more. You have a setup for, this is just an example where you offset one row of seats to get more shoulder space. If you're sitting side by side, the shoulders are touching. If you just move 2 seats back, you get more space. Same console, angles, bring back the wheel. Yeah, this is another key thing to consider, that it's natural to put the steering wheel in the center, but no one drives a boat like this. Everyone has one hand on the wheel and one hand on the throttle. So what happens when you have the wheel centered and the throttle offset is not that you're not going to sit like this driving. You're going to sit like this driving, and you risk injuring your back. Yeah, I'll run through this a bit quickly. Here are just examples. You can see the footrest pipe. Make sure that there are footrests. Make sure that the footrests are attached to the boat and not to the seat. You need the guy to be able to use his legs to brake. You need to feel what the boat is doing, because you get so much tactile feedback from that. And that's especially important if there is poor visibility, if you don't have all the sight that you want. You need to get the information on what the boat is doing, both from your hands and from your feet. Yeah, here's another console with a jockey seat in the center and 2 other guys showing the offset, where same thing with bringing the screens back and offsetting the seat. So cockpit layout instrumentation. Displays, do we put them on the seat? Do we put them on the dash? Controls, do we put them on the seat? Do we put them on the dash? Generally, our take on that is that if you can if it's a fairly forgiving boat and you can sit and relax and take it easy, fine, put the joystick on the seat. But if it's a boat where you might need to hold on and you're driving harder, you might be better off with having the controls on a surface attached to the boat, because you'll get the feedback from what the boat is doing through your hands, and you will have the possibility to hold on. I'll skip that. So sitting, the importance of posture. You don't have to be a doctor to see that the guy on your left is better off than the guy on your right. Most of you are sitting like the guy on your right here. And that's not because you're sitting bad, that's because you're sitting in a traditional chair. That's what it looks like, and that's what it looks like. So when this guy gets exposed to a lot of force, he's just not in a position to take it. So when you're exposed, don't sit like this. That also requires more from the cockpit. Okay, we'll skip that. So standing. So you're not supposed to sit, or you're supposed to stand. Why do you want to stand? You can't trust the seat, but can you trust your legs? You have this, there's a trend with flip down and flip up seats. It sucks. We have them too, just because they're in the specs, but flip down and flip up seats are useless, because basically what the flip down does, it takes away the seat. So if you have a great seat, even if you just crouch sit on it, you should never flip it away. Then you can just get, save the money and get something else. There's no need to get a flip down seat, because it allows you to stand. But let's develop on that. Why do you need to stand? Do you need to stand to see out? Do you need to stand because you can't reach some instruments? Do you need to stand to get in and out quickly? Does the boat design require you to stand? Can you change the boat design so you don't have to get up and stand? Because when you're standing, you're exposed to more force. This graph quickly illustrates that you're almost, a standing guy gets almost twice the impact on his L4 vertebra that compared to the deck. That's a fact. So you're not better off. And now, of course, none of my videos are running, so we're going to save some time there. Briefly, you can say that the reason the guy is getting a worse impact than the boat is that the boat is landing in the water and the guy is landing on the boat. The boat is harder than the water. You can see here the difference between a guy sitting in a sit-down seat, Daytona seat up front, a guy using the seat the right way, a guy using his legs too much, and a guy standing. You can see that they crouch. Let's see if this one runs. Okay, so what about flip up seats? To say, you say, okay, we have to have flip up seats because we have to save the space. Okay, so here's an example from a recent tender in a Nordic country where it said we have to have flip up seats because we need space for boarding. Okay, so let's look at this. We said, okay, but if you can get the same space but you don't have to flip anything up, no, that can't be. We have to flip. So this is not a special product. This is a standard, jockey seat. Here's a flip-up seat. This seat has, okay, that sits outside the slide now. But when these are useful, this is 1.019 meters. This total up here is a bit more, 1.2, something like that. So when you flip it up, you can use one seat, you can't use the other, you're at 1021. So with one useful seat and one useless seat, you have more space than you do with two useful seats. So why put fold up or fold down in the spec? Spec the surface you need, let the boat builder decide how to configure the boat. In the end, I'm sure the guys are happy to not have the hassle to fold things up and down, because it doesn't have its own value. You need the space, so spec the space. That's why I want to get, there are a lot of people writing specs here. Don't spec their seats, don't spec our seats. Write a functional spec, what you want to achieve, what you need in terms of space, and give it fair competition. What about height adjustment? Some of you heard this before. The question is, do short people want to sit higher or lower? Anyone? Short people don't want to sit lower. They really don't want to sit lower. They might not have to sit higher, but they want to sit at least as high as the other guys. So if you spec height adjustment, give it a thought. Why are you speccing height adjustment? Spec sight lines instead. Make sure that whatever you get, maybe our seats, maybe other seats, maybe fixed seats, maybe standing bolsters, but make sure that what you spec is, why do you want them to sit higher? You want them to sit higher to see out? Spec sight lines and leave it up to the boat builder and to the manufacturers to give you that performance. Sight lines are important because if the short person is sitting lower, they're not going to be safe because they're not going to be able to see what's going on. They're not going to be able to see where they're going. And as so many speakers have talked about, the element of surprise is very closely correlated to accidents. So we don't want to surprise our guys on the boats. We want them to all be able to see out. If you want to cope with shorter person, let them sit at the same height, bring the foot supports up. Really quickly on springs. We've been touching the subject. I'm just going to give you, I'm sure a lot of you know this, but I'm just going to give you the quick 5 cents on this. Traditional coil springs, you can trust them. They're proven. The problem is that you don't get great stroke from uncompressed to fully compressed. You need a long spring to get a long stroke. They can't be stainless because you don't get good stainless spring steel. You have to coat them, and they're heavy. A trend we see now is air springs, which is basically a damper with an air cushion in it, a closed capsule. In theory, air springs are great because they're very progressive. You can adjust the air pressure to get different characteristics of the seats. We are not pioneers. We are not, you know, we have to be humble. The seating companies, we don't pioneer any new development in, say, spring technology. The motocross industry does. So the motocross industry, for 2 years, a few years back, they went over to air springs. But they found that the possibility of breaking an air spring because they get new dampers for new springs for every race. The odds of breaking an air spring in one race was too big for the benefits. So they went back to conventional springs. This is an issue with air springs with everyone that uses them. You have the nice gadgets, you can pump them up, but what happens is when you get these bottoming out forces, the air pressure inside the damper gets infinitely high, and you blow the gaskets. They might leak, they might break, they might blow out, but it's not a reliable type of spring. Our take on this is leaf springs. So you remove the moving parts, you remove all the pressure, the gasket. You have two springs that are firmly attached. This is a system that we use for all our products. This is what it looks like when it's compressed. Nothing to service, and it gives you very nice damper spring characteristics. The other feature that it gives you is you don't restrict the motion to a linear guide. If you have something running on rails, it cannot run anywhere else. It has to go on the rails. If the force happens to come from the side, the rails can't shift. They still need to go in their line. This system, let's hope this video works. This shows you what happens when you have the leaf spring system and you get sideways forces. The seat cradles you, and this is very hard to achieve with any other system. That being said, the sideways forces are also more dangerous injury-wise than the pure vertical ones, and everyone that's been thrown aside and hit their ribs know this. So I will leave it at that.